So this is 1969, number 30. We're told at -1, 4, we have a relative maximum. And then at 3, -2, we have a relative minimum. So that's a max, a rel min. I'll put an R for rel, relative. Okay, what must be true? Okay, the function's continuous everywhere. Okay, and we could have other relative max and mins, we don't know, but we know for sure they have them there. Do you have to have an inflection point between these two, between 1 and 3, -1 and 3? And some might say yes, because like, okay, there's relative max, there's relative min, so somewhere it changed from concave down to concave up, right? You might think that, but can't it be straight lines? And since straight lines don't have concavity, there's no inflection point because concavity doesn't change. So be careful about the assumptions you make about what the graph looks like. So A does not have to be true. It might be, it could have, but it doesn't have to be. Then they're saying the derivative at 1 must be 0. Do all relative max have derivatives of 0? The answer is no. You could have an undefined derivative, right? It could be a sharp point and have a relative max. So just because you have relative max doesn't mean that the derivative is 0. The graph of f has a horizontal asymptote. Okay, a horizontal asymptote. That means as I move to the left or to the right, it has to approach a certain number. And nowhere in the function does it suggest that, right? I know I have a relative min there and I have a relative max there, but do I have to approach a number as I move to the left? Can't this just go down? And can it just go up? It can. So you don't have to have a horizontal asymptote. So that doesn't have to be true. So I just gave you examples where it doesn't have to be true. So that is a silly concept. Let's keep going. F has a horizontal tangent line at 3. And again, if there's a relative min there, does it have to have a horizontal tangent line? And the answer is no. Can't it be a sharp point there? And then it doesn't have a tangent line there? So max and mins can occur if the derivative is 0 or a horizontal tangent line, or if the derivative does not exist. We don't know what's going on there. It could be either one, so it doesn't have to have a horizontal tangent line. The graph intersects both axes. This is the answer. Watch. In order for me to connect these, to go from here to here, I have to cross this axis and that axis at some point. It must cross both axes. So E is the answer. The graph intersects both axes.